Hi. I don't know how well this is going to work because I'm using my phone and I would rather use something a little bit more professional, but I just thought about what we're doing today. Regarding dividing fractions. I would not recommend doing this first in the lesson. Instead, I have something else I'm going to send you that I would recommend doing first that involves serving size of cookies. But I still want to show you what it means to divide fractions. So what I'm going to do, I'm left-handed, so I have to swivel my paper. What I want to do is I want to show you something like 9/4 divided by 2/5. Now this is without an algorithm. So I would invest the time talking about what it means to divide, even with whole numbers. What does it mean to divide? You want equal groups. How many groups of equal things? And that's really what we're doing here as well. So you want to help them build concepts of fractions as well. And what does 9/4 look like? So let's draw 9/4. All right, there's a whole. And if you split it into fourths, that's 4/4. So you need another whole. And if you split it into fourths, that's only 8/4. So we need another whole. Act like these are the same size, please. I can't hold my phone and video at the same time. So what does 9/4 look like? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. That's 9/4. You want to divide them into equal groups, all containing that amount. And this is where kids go crazy because they don't know what that amount is. So let's look at what that amount looks like. But we're not going to mess with these. We're going to draw it separately. What does 2/5 look like? Two-fifths is two of these guys. And I would stop here and ask them what they notice. You're trying to find out how many of these blue things will go into the yellow. Well, what bothers them? Well, it should bother them that they're not the same size. It should bother them that they're not the same color. The reason they're different colors is so we can talk about the different parts. You're trying to see how many of these blue pieces will fit into the yellow pieces. But it's difficult to do because they're not the same size. If you've spent time with multiplication of fractions where you're merging the two and coloring and finding out where they overlap, this won't be too difficult of a concept. So in order to make them the same size, you simply take this figure and overlay it here, and this figure, and this figure, because all you did was take those and put them up here. And now guess what else you're going to do? You're going to take these and move them here. So now you have pieces of the same size. So this becomes same problem, just a little different. How many of these blue pieces will now fit inside of these yellow pieces? So look at it. They can literally count them at this point. 1, 2, 3, 4, 5, 6, 7, 8. So for every 8, I have a group. There's one group. There's 2 groups. 3 groups. 4 groups. But look here. 1, 2, 3, 4, 5, 6, 7, 8. There's another group of 8. They just aren't nicely stacked. So there's 5 groups of 8 little rectangles. I don't have enough to make a group here. So I have 5 whole groups, and I have 1, 2, 3, 4, 5 out of 8 that I could not combine. That's your answer. 5 5/8. Does it make sense? Here's where your math thinking comes in also. Here's where the estimation plays in. How big is 9/4? Well, it's more than 2. How big is 2/5? It's less than half. These are great conversations to have in a classroom. So you're taking a number that's less than a half and fitting it inside of a number that's more than 2. So your answer should be around 5 and something. And when you start having those conversations, then they will know that the answer starts to make sense. Now, if this were me, I would erase this and start all over and do the exact same thing again. But in the second time, as you do this, here's what I would write as well. When we split up these, what did we form? We formed 45/20. If you were to count those, we colored 20, 40, 41, 42, 43, 45. We colored 45/20. What did we color here? We colored 8/20, because in order for us to divide, they had to be the same size. So when we divided 45/20, and this is really, really ugly, we typically don't write it this way, divided by 8/20, because these are the same size, we really only had to divide 45/8. That's where your algorithm comes from. If you were to do 45/20 times 20/8, that would be 45/8. If you were to do 9/4, which is the same value, times 5/2, you'd get 45/8. That's where that comes from. The fact that you're making those pieces the same size. So I hope that's helpful, but I would not do that on the first day or the second day or the third day. There are other things you can do to build up to this, but this is why the algorithm works. Anyway, thanks.